Now that should be showing up as near-Earth asteroid observations, principles, and practice. Do you see that? Looks good? Okay, well, let's go. This is an occultation path of a high rank event. It's a Preston rank 99. It's 2483 Guinevere's rank 99 event of August 6th of this year, just about a week ago. The bold yellow line is the predicted center line. The blue lines are the path edges, and the red lines are the 1 sigma and 3 sigma uncertainty lines. The map distance key is in the lower right, and it shows a 20-kilometer width, and you'll notice that distance key is approximately the same as the uncertainty zone width. This Google map is at the same scale as the last one, but shifted to the northwest somewhat. The path here is that of the near-Earth asteroid Didymos for an occultation on June 25th of this year. Ignore the green lines. Those are just for observers' coord assignments. The important lines are the red lines narrowly seen amid the green lines. Those red lines are the 1 sigma limits. The actual path edges may be difficult to see at this resolution. The path edges are the blue line between the two red 1 sigma lines. The blue lines appear as one line in this view due to the limitation of the map's resolution. The point here is that the path is very narrow, but strikingly, the 1 sigma uncertainty zone is very narrow in comparison to that of the main belt asteroid Guinevere on the previous slide, despite the fact that the Guinevere event is of quite high rank. Here I have superimposed a couple of red lines that are 20 kilometers from the path edges of the Didymos event. That is, these red lines are spaced the same distance they are spaced for the Guinevere event shown previously. This is simply to display how greatly the path error for a main belt asteroid like Guinevere is likely to exceed that of a near-Earth asteroid like Didymos. When standard astrometry results in good path data, such as this Guinevere 20-kilometer across path uncertainty, how does it happen that some near-Earth asteroids, such as Didymos, have an uncertainty zone of only a few kilometers? This slide can be confusing. It shows the improvement in the uncertainty of the Yarkovsky effect estimate for asteroid 99942 Apophis over the last 8 years. Time is on the abscissa in years, and the estimate of the Yarkovsky effect, and it uses units that we don't need to go into, but the estimate of the Yarkovsky effect is here on the ordinate. Although the graph does not show the orbital model's error, that error in the orbital model is roughly proportional to that of the Yarkovsky effect. So I am using the Yarkovsky effect. As a proxy for the accuracy of the orbital model. Note that the refinement in 2021 was so great that it had to be dealt with in a separate expanded box here in the upper right. Along the abscissa are 2 Earth symbols, and these are designate the times of close approach. One in December and January 2012, 2013, and the other in early 2021. Apophis makes such close approaches every 8 or 9 years. And the next one, the next close approach of Apophis, as you may recall, will be in 2029, when it will pass closer to Earth than our geosynchronous satellites are located. This diagram was created by Paulo Tonga. Apophis was discovered in 2004 and was immediately identified as a near-Earth asteroid. Its first radar astrometry was done at Arecibo in 2005. As I said, it comes close to Earth approximately every 8 or 9 years, and for most of the rest of the time, it is too close to the sun to observe. The circled data show the large uncertainties which do not overlap on two measurements and which disagree on whether the effect is positive versus negative. This was the state of this measure in 2013 after a close approach to Earth, and this included radar astrometry from both the Goldstone radar in late 2012 and the Arecibo radar in January of 2013. The next close approach to Earth was in late 2020 and early 2021. And during this time, the orbital accuracy measured by optical astrometry was rapidly improved, as shown by the data in the two ovals. And keep in mind that the larger of these two ovals is this one right here. And you notice the gray, and this is just optical astrometry that has made the difference. And then it improved further just due to optical astrometry during 2020 and 2021. This improvement was by virtue of the close approach, plus the advent of the Gaia astrometry data. The asteroid was sufficiently close for Goldstone radar astrometry in the first few days of March in 2021, and this radar astrometry resulted in a 60% further reduction in the uncertainty in the measure of the Yarkovsky effect. It also brought the orbit uncertainty down to a level that suggested that a campaign of IOTA observers assembling in Louisiana had a good chance of recording an occultation. This shows the improvement after a single positive occultation event that in Louisiana on March 7th of 2021. This one occultation observation decreased the uncertainty by about another 50%. Following this, a number of subsequent positive occultation observations were made, further refining and verifying the orbit, but the data from these observations is not shown here. Item D you see to the right there is something else. So what were the factors that brought about the very low uncertainty in the Apophis orbit? Firstly, a close approach to Earth. The nearer you are, the better we can measure you. Secondly, updated optical astrometry using newly available Gaia data. Third, radar astrometry shortly before the occultation observation. Fourthly, broad coverage of the residual uncertainty zones by a campaign, an IOTA campaign, so that an occultation could be recorded. And finally, subsequent occultation recordings that localize the asteroid with an accuracy of a small fraction of its diameter. This shows a similar multi-step process had previously led to a positive occultation observations with 3200 Phaethon. Astrometry by the Arecibo instrument had already been done, and its orbit was well known, in part due to a 35-year observation period. A joint occultation campaign by IOTA and the Southwest Research Institute in the Western United States in 2019 is described in the caption of this diagram. There were 66 chord lines, most of them filled, and the green ones in the diagram are those manned by the SWRI observers. There were 6 positive chords. The first occultation campaign by IOTA for an event by Apophis was on March 7th, 2021 in Oakdale, Louisiana. The observers' chords are shown here. Note that there are 3 different paths drawn on the map. We have the JPL 2004 center, the JPL 2011. Those numbers are the orbit numbers. They assign each orbit calculation a number. And Buie came up with another 2004 center, and this one was Irwin's, which I think may be Buie's, which is elevation corrected. You can see that there was some cross-path uncertainty, and fortunately we had enough observers to result in 3 positive chords. The positive chords are here in green. The Dunhams had 2 stations positive, and Richard Nugent had 1, and the red stations are those that were negative. Similarly, we have attempted to have large campaigns for the Didymos occultation so far in 2022. This picture shows the sites of my 6 telescopes along Route 441 bypass around Dublin, Georgia, for the Didymos event of July 24th, 2022. The center line is the bright yellow line. The path edges are the orange lines. The green lines are for chord assignments. There are some fainter red lines here, which are the 1 sigma uncertainty zones. Jack Jewell set up on the center line in southeastern Montana, and I spaced my stations 600 meters apart on each side and set up 3, basically covering the 1 sigma zones with just a little bit to spare. Occultations by near-Earth asteroids have narrow paths, but the ones we try to observe have remarkably accurate orbits with uncertainties much smaller than the orbits of main belt asteroids. These accuracies have been achieved by virtue of the asteroid's closeness to Earth, the availability of new Gaia data, and the ability of radar astrometry to reach them. Most main belt asteroids cannot be reached by radar astrometry. And the paths are enhanced by the high level of interest in these objects engendered by astronomers, including ourselves. The Gaia data will degrade gradually during the coming decade. Therefore, we are now in a time period of a few years that will allow unique opportunities to observe occultations by near-Earth asteroids that were not possible in previous years. Because the shadow paths of near-Earth asteroids are so narrow, it is highly unlikely that any will pass over your home observatory. To observe these events, you will need to become a mobile observer. Recall that the observation of lunar grazing occultations require observers to be mobile, so mobility is not a new idea to IOTA members. Now I want to change the focus of this presentation to a discussion about mobile stations. I want to give you an idea of how I select mobile observing sites. This is a Google Earth overhead view of an area of paved road that has a couple of good sites along it at which you might set up a telescope. On the left, over here, there is a building, and if you look closely at it, you can see that it has a steeple. The street view shows that there's only a small security light in the right front northeast area here of the building. So that the best site here is not on the driveway, but just behind the building in the shadow. And this will involve a carry of your equipment of fewer than 100 feet. I usually do not plan on using a church site on Sunday nights because many churches have meetings on those nights. On the right side of the view, you see a dirt road that goes up, turns sharply right, and then turns sharply left. Now, Google Earth will allow you to explore this road far out of this field of view up to the north. And in this particular case, there are no homes along the road, and the road peters out in a tree farm. I stopped along this road about 200 feet up at somewhere about there, couldn't be seen by the road from the road, and I set up a telescope. The point here is that there are 2 good sites in this view, and they are exemplary of the type of site that you should look for when you set up a mobile observing station. This is a Google overhead view of a Coca-Cola bottling plant. Remarkably, its security lights are only in certain areas, mostly right on the building, and the parking lot to its north has no lights. Because trucks sometimes pull into a distribution center at night, I prefer in this case not to set up anywhere on any of the pavement, but rather in the grass to the north. Now you'll notice there are trees around, but if you need to know how tall those trees are, you can always find out from a Google Earth view. You find out by looking at telephone poles. Now there are telephone poles around the highway here, and if you zoom in on them, you can see their shadows. Telephone poles in this vicinity tend to be 30 feet high. So you can look at the shadow of a telephone pole, find that it's 30 feet high, and compare it to the length of the shadow of the trees here, when you see those shadows, and thereby do elementary arithmetic and find out how tall the trees are. And that's sometimes very important if you have an event at low altitude in the sky. There are two other good sites in this view. One of them is down here at the lower left. If you set up rather far from the road in this area, you'll notice there's a recess amid the trees here. You can set up in that recess, you'll be well hidden. And if the event is in the west or the northwest, that will be an excellent site. Another good site is along a 2-rut dirt path that goes up between the trees here, right up to here. And you'll notice right here, there's a gap in the trees. And if you have a observation to make in the southwestern sky, you can set up right up in this area and have an excellent view. So there are 3 sites just on this view. The potential observing sites that I have just showed you are typical of those that I use for main belt asteroid observations. Such main belt events allow substantial leeway in the spacing of the stations, perhaps a number of miles, even when there are other claimed chords, due to the width of the path and the uncertainty zones. However, such sites are unlikely to be useful for near-Earth asteroid observations. The reason is that due to the very narrow path width and uncertainty zone, you will be constrained to set up within a small distance of your assigned chord. I mean 100 meters or less. For near-Earth asteroids, I've been using a particular type of highway, and I've done this a number of times now. Certain highways provide excellent wide shoulders for the setup of telescopes. These are federal divided highways, not including any highways of the interstate system, as it is not legal to set up along interstates. Most federal divided highways have shoulders about 70 feet wide. This Google Earth picture is a close-up of the 6-station view that I showed several slides ago. US Route 441 includes a divided bypass highway around Dublin, Georgia. The shoulders along the bypass are 70 feet wide or more. The yellow lines that are drawn over the pavement are actually wider than the pavement. And if you zoom in a lot, you can then see the width of the pavement. Down here, we have the distance key, the Google Earth distance key. And what I'm telling you is that the distance of this telescope site from the pavement edge is nearly 100 feet. This is typical for this stretch of road. A shoulder of approximately 70 feet width is typical of major federal divided highways, if they're divided highways, like this one, though some are narrower. These 2 photographs are self-explanatory. I wish you to notice the remarkable resemblance between a black cat and a black telescope. For those of you who have never set up a roadside telescope and are afraid that passing headlights will illuminate your equipment, I encourage you to actually try this. After painting your equipment a very dark color, set it up at night in a field about 70 feet from a road and drive past it to see whether your headlights enable you to discern it in the dark. Under such circumstances, I cannot see mine, and I have never suffered the theft of equipment by passers-by. Because the path is so narrow, the shadow will miss you if you try to observe it from home. You need to go mobile. This slide shows David Dunham setting up a suitcase telescope of 250 mm aperture. Except for the optical components, it is homemade. The altitude and azimuth pointings are controlled by hand screws, but also allow fast sliding for the making of the larger pre-pointing movements. Telescopes such as this can be transported in ordinary baggage and used for observations anywhere in the world. John Broughton originated this particular design. The Dunhams also use these 120 millimeter refractors mounted on homemade altazimuth mounting, scaled down from the one on the previous slide. The miniature computers, miniature monitors, miniature batteries, and the video time inserter are also shown here. These electronic components are scaled down, making it easy to travel with them. I use a different approach. This is an ordinary Celestron C5 Schmidt-Cassegrain on an ordinary C5 equatorial mounting. It is easily transported, but requires a moderately large box. And I note that I use an ordinary laptop computer for recording. The computer is in the blue box in the front of me. Also, I use heavy but inexpensive boat batteries. Right down here is the black battery for power. They're the deep discharge type boat batteries or recreational vehicle batteries. A gap in the trees along a roadside, such as that behind me, can be used to hide a telescope. I call this particular telescope my John Westfall C5, as I purchased it from his wife Elizabeth after his death. When a telescope is to be set up using the pre-pointed method and left unattended, always place boards under the tripod feet to prevent them from sinking slightly into the ground over time, thereby ruining the accuracy of your pre-point. After placing them, I step on the boards with my whole weight in an attempt to complete the settling of the tripod prior to pre-pointing. I have lost many a station by misconnecting the battery terminals in the dark. I cannot see the blue smoke in the dark, but I can smell it, and I can hear the fizzle in my electronic components when I connect the batteries backward. Now, all my batteries are prominently marked by bright red tape around the positive terminals, so I can more readily see which terminal is positive in the dark. The C5 came from the factory with a small finder scope of only 25mm aperture, enabling me to see stars down to magnitude 7.5 or so. I highly recommend replacing a small finder with a finder of 50 or 60mm aperture, enabling the detection of stars to magnitude 9.0. This 50mm finder was made by cobbling together a bunch of spare parts and building its on-scope mounting. The use of a large finder such as this will prevent the telescope from fitting into its factory supplied case, so you will have to make a padded box in which to carry it. The dew shield is always needed in the southeastern United States. I have found that it may not be needed if you're in Arizona or West Texas. A dew heater in addition to a dew shield, that is a heater with a nichrome wire in it that actually warms the corrector plate, is often needed for Schmidt-Cassegrain telescopes larger than 250mm, but it's generally unnecessary for small Schmidt-Cassegrains. The dew shield is homemade, a roll of cardboard. The dew shield is glued into a roll on only one end of the roll. This allows the other end to expand a bit, shown here by the admission of my index finger, so as to slip over the end of the telescope snugly. The use of a bungee cord may be optional when the dew shield is new, but after repeatedly getting wet with dew, the shield will have only a weak grip on the telescope and the bungee cord will be necessary. It seems a good idea to leave a message somewhere on your unattended equipment. In preparation for this talk, I hope this is encouraging to you. In preparation for this talk, I counted approximately 425 unattended telescope setups that I have made. Of these, 2 that I know of have been discovered and left untouched. 2 others were molested by policemen who mistakenly thought their touches were too light to disturb the pointing. I know that because I encountered both policemen. None were bothered by anyone else, none of the 425. Perhaps a lot of them were discovered and this sign was read and the equipment was left alone, but I'll never know about such cases that did not call me. In the state of Georgia, be ready for rain when the forecast is for a clear sky. As an example of an occultation by a near-Earth asteroid, this slide presents the light curves of the 3 positive occultation chords of the first Apophis occultation observed in the Iota campaign in Oakdale, Louisiana. Notice that the occultation was very brief. 3.5 frames duration here. There are 3 occultation frames and 1 of intermediate brightness. 3 frames here. I hope you can see this. I'm having a view of 4 observers here, including 4 participants on this side of the slide, but this is a 1-frame event. recorded by one of Dunham's stations.
We can see it fine, Roger.
Okay, good. The brief duration of this event will lead us into my next presentation. But before we go to the next presentation, is there any discussion, any questions, any answers?
I was just going to comment that with your battery connection issue, use the old style bridge rectifier in your cabling, then you don't have to worry about which terminal is which on the battery. Ah,
that's something I'm unaware of. Perhaps show me where I can get one.
It's just an array of 4 diodes, and they're wired together such that whatever the voltage goes in on the 4 diodes are sort of connected like that. One that way. You put the cables in on one side of the triangle, the quadrilateral, if you like, and you take the power out of the other, and you orient the diodes correctly, irrespective of the voltage, the polarity going in. You always have the correct polarity coming out. You lose a little bit of the voltage, but not much. But it means you never have to worry about misconnecting the cables to the battery. A really very cheap, but saves loss of expensive equipment if you misconnect.
Yeah. It's been an extremely frustrating problem for me, and this counts for a number of my failed no observation events. So what is the name of that type of diode again? What do you call it?
It's called a bridge rectifier.
Bridge rectifier.
Bridge, as in what you cross a river with.
Bridge, yeah.
And I think you can buy them as a single chip, or you can buy them as just use 4 single diodes and solder them together. Yeah. It's a really, really, really simple thing, and anyone with a soldering iron, even a plumber's soldering iron, can put one together.
Yeah.
And
thank you very much for that information.
I'll mention another option is they do make cables which are polarized. You can only plug them together one way. You can fix your cables to your battery instead of using clamps. You can fix the cable to the battery, which has a polarized connection on one end, and then on the other end, you have a cable leading your equipment, and you can only plug it in one direction. So there's no way to connect those 2 cables without doing it correctly. That's something I'll have to look that up to provide later.
We use these lithium batteries. Let's see, it looks like I disappeared. Anyway, they're from Talent Cell, and yeah, they're more expensive than the boat anchors, but on the other hand, how many times do you have to replace your equipment before you decide that maybe something else is better? But yeah, they've been lasting very well, so we're real happy with them.
Roger, I would like to add one note. So I have implemented a fairly bright green laser into my installation, and it's invaluable. It's better than a finder because I align it with my telescope axis, the optical axis, and almost in very bright twilight, I can follow it to a pointing star or a hopping star, and then when the green laser is on the star, it's in the center of my video monitor. So I don't use a finder anymore. I think it's an invaluable tool.
Good. Yeah, I know a number of observers use those. I've been using finders since I was 10 years old, and I've established a certain amount of skill with them. It comes very natural to me, so that's why I do that. But the 25 mm finder is not sufficient. You need one that's going to show you 9th magnitude stars. That's the way I look at it. So anyway, any other comments?
Another suggestion.
I'm sorry.
Go ahead, Richard.
This is Richard Kelly. Yes, I was wondering with regard to your mobile site selection, do you ever feel like you need to get permission or, I don't know, register with local authorities? For example, the Coca-Cola plant you showed, I can imagine, people being seen on security cameras and police being very,
I don't
upset
mind
about you being on private property.
security. Your bank has security cameras. That certainly doesn't mean you're not allowed to go into your bank. Walmart parking lot has security cameras everywhere. It doesn't mean you're not allowed to go to Walmart. Security cameras mean nothing. And by the way, if any mishap happens or crime, for example, occurs, there's nobody sitting there watching the security camera. What'll happen is that eventually it'll get reported to the police, and 2 days later, somebody will discover that the security camera showed it. So, security cameras are not important to me at all. What is important is obeying the law about trespassing. And now, I think that from the standpoint of security, I think probably a lot of people are a little bit afraid of the dark. A lot of astronomical observers. That is, it's a scary thing to set up along a road, or to go to a place and pull into a parking lot and set up on the grass next to the parking lot. It's a frightening thing if you're not accustomed to doing it. And when I said I had 425 cases, those were unattended telescopes. I've got nearly 700 if you count all my cases. And so I just think what you need to understand is that generally people feel just as you do at night. Now, if you pass a car parked along the roadside, say on the shoulder at night, or if you see a car that's in a parking lot of some business at night, are you going to care? No, you're driving down the road and you're going to continue. People are not interested in bothering you. And if they were to bother you, they would be terrified that you'd harm them. So this is the real psychology behind setting up a telescope at night. And it is illegal to go past a no trespassing sign. Or a posted sign. We have in Georgia, and I know I lived in New York and in Pennsylvania for years, they actually specify in the law what a reasonable distance between such signs is, so that if someone has extensive property, they're supposed to, in New York, it was every 300 feet, they had to have a posted sign, or it was legal to trespass. Things like this. I wouldn't want to emphasize that you look for gaps between posted signs. What I want to say is that people do post their property, and I always look for such signs. A gate, you don't go past gates unless they're open. A closed gate, it's illegal to open it and go through it. It's illegal to go across a fence, a barbed wire fence or some other fence around property. And I avoid doing those things. So, and of course, I always look for signs. Generally speaking, people just don't, they don't care any more than the Walmart parking lot does when you pull into their parking lot of a business at night. They just don't want you to bother the business, and they don't post the business. And businesses that do care about that put a fence around the business, and they put a gate up that they close at night. That much is so simple that you really don't have to worry about it. If there's no gate, it's legal to go in.
Yeah. Okay. Very good. Thanks.
Roxanne had a question.
Actually, just a quick comment about connecting cables in the dark. I like to use a whiteout pen and just put like a dot on the cable and like a dot on the back of the camera. So I know if I line those dots up, it's easy to plug them in. So I'm not fumbling around with my cables at night or such. So I find that using a whiteout pen to mark my equipment, like your battery terminals, put a big white dot or a big white X next to the red one, and then that's the terminal to plug the red to. So just an idea.
Yeah, thank you for that.
There's also this glow in the dark tape that you could maybe just use on the hot terminals.
Yeah.
Roger, Kevin Hartnett, just to follow up on placement of these things, it sounds like in most cases you don't desire or need to coordinate with somebody. But I was wondering on the other side of that, like if you identified a church parking lot like you did, or a school parking lot, do you have any experience to share about trying to contact these groups ahead of time, and whether that's worked out good or bad, whether people are generally, acceptable to that or not? I would think that they would be, but I haven't done it, so I'm just kind of wondering.
I have limited experience with contacting people in that regard. When I was doing grazes in probably around the year 1990, a couple of times I called the police to tell them that I'd be setting up a telescope on a certain location next to a road or something. And I did this because I read in the IOTA occultation newsletter that it was good to do so, to notify the authorities that you would be there or something. And so I notified them a couple times, and they were completely disinterested. They didn't care. You could tell by their vocal tones that they couldn't care less about me setting up a telescope along the road at night. And I just figured out really quickly that you don't need to ask. You don't need to tell the police. Okay. Anyway, one time I know David Dunham used to ask homeowners, and he'd set up in their yards. He'd ask them for permission, and that has occurred to me. That has happened to me a couple of times, and in each case, the person was very kind, and he showed me a great place to set up. And it took him forever to stop talking, and I was very distracted from my expedition, in which I was trying to set up a number of telescopes, when I could have found the same spot, which was unfenced, along a dirt road somewhere. Could have found it quite handily without any help, and perhaps an even better spot, because I've looked at the heights of the trees on Google Earth, as I showed you, so I really knew where to go. So, in general, speaking with people, I consider to be more of a hindrance than a help.
I'll offer two experiences. One experience, I set up a scope at a vineyard, actually a winery in Washington State. And it was helpful to actually stopped and talked to the security guard, who was very helpful, and fortunately turned off the sprinkler system that would have gone on at night, and watered down my telescope had I not talked to them. So in that case, it was very useful to talk to them about it. And in other cases, I often try to talk to people if I can. Another place I talked to another winery, and again, they were very helpful. And then on the police, I often call ahead just on the chance that even though they usually sound disinterested, don't really care. But in that case, if someone did call in and say, I saw something going on over there, they would know what it was, and they'd be less likely to stop by, maybe shine their lights on it, maybe mess with the scope. So if it's easy, I try to do it. The one other comment from the same time I set up on at the winery is I was setting up near Yakima, Washington. I called ahead to talk to, in this case, it was part of the Yakima Native American tribal land, and I called them ahead of time to say I was thinking about setting up along the U.S. highway, and they basically told me I'd be arrested.
Yeah.
So that was very useful to know that I did not want to set up there, so I changed to somewhere else. So sometimes it's useful to call ahead and check.
Yeah, I deliberately avoid Indian reservations, and please understand it's solely a matter of not knowing their local laws, and they do have local laws that I'm just not going to be familiar with, and so I avoid them for that reason.
I think they've gotten pretty tired of being treated like a tourist attraction. And in Arizona, some of them say that if they catch you parking along the side or attempting to climb one of their mountains, they will take your car. That tends to stop people.
Yeah. Okay. Well, thank you for all these thoughts. Rick, were you going to say something more?
Me?